Yes, good morning everyone. Can you able to hear me? Abhishek, Nishita, Rutvi, Sanjana, Shreyas. Am I audible to everyone? Can you just confirm please with yes or no? Yeah, you can start your mic so I can get the idea. Okay, fine. Great. So nice of you. So actually, this is the lecture conducted by the Shreya sir, but he is in meeting right now. So actual lecture will start by the 11:30. So up to that time, you can do your assessment work. Suppose that if you have any quiz assignment or any pending task, you can solve it by the 11:30, and sir will be joined by the 11:30. So you don't need to leave the meeting. Just be present here. Sir will join within the 15 or 20 minutes. So start your task. Thank you. So if anyone is present at the campus, they can come to the class number MA 211, MA Bushogi. Yeah, those who people joined the late, I already give the instruction that sir will be joined by 11:30 because right now he's in some important meeting. So just take a present up to that time and you can finish your task like assignment or any assessment that is pending for you, and you can complete up to that time. And then after sir will going to take your lecture. Yes, Abhishek, tell me.
Good afternoon, good morning all. Mute करना जरूर. Okay. Aditi, Darshad, Drasti, Anil, Vrinda. Hello. Am I audible, all of you? Jaishankar or yes, anyone can say that what are the last topic we had discussed in your class? I don't know. That is why. Anyone, what are the topic, the last topic we had discussed? Anyone? I don't know. After so much time you had joined. Maybe અત્યારે બધું થર્ડ સેમેસ્ટરનું યાદ રહેતું હશે, ફોર્થ સેમેસ્ટરનું ભૂલાઈ ગયું છે. કોઈને કાંઈ યાદ હોય કે લાસ્ટ આપણે શું કર્યું હતું, કોઈ ટોપિક યાદ છે? અહીંયા બેઠા છો. કોઈ બુક બનાવી હોય? હે? એટલે યુનિટ 5માં આપણે એડ્રેસ સિક્વન્સિંગ ચાલી ગયું હતું. 0 એડ, 1 એડ, 2 એડ, 0 એડ્રેસ, 1 એડ્રેસ, 2 એડ્રેસ. Those who are online, I'm asking to them also. That is completed, the 0 addressing, 1 addressing, 2 addressing. That's પૂરું થઈ ગયું હતું. So we'll go to unit 5. Please start from beginning. Okay, let's start from beginning the unit 5. Till the unit 4 clear, correct? Okay. Unit 5, it's like a central processing unit. It's very important topic for the exam point of view or the GTU exam also, okay? So these are the things we are going to discuss in this total unit. Like I have a general register, stack organizations, addressing modes, data transfer, program control, and risk instruction. We'll start a component of the CPU. The CPU means everyone knows that it's nothing but a processing unit. It can able to do the process on any data. Okay. So if you look at what are the two things we have register sets and ALU, and we have a control unit. Can anyone say why we use the register set? Register set. What is the reason to use the register set? Anyone? Parthiv, Keval, Yash, Cheshankar. Ravinder is not been always be there in the class. Store the data. Very good. That means I must require how much of register? If I have a processor with a more register or processor with a less register, which is preferable? Which is preferable? Processor with a more register or processor with a less register? Which is preferable? Okay. More register is more preferable, correct? But if you use more and more, what happens? It will consume the more space in design. So it's not that good to have a more register. It's not that good to have a low register. It's okay if you have a moderate, like the medium kind of a registers what we have. But we must require registers. And you know about the ALU, that is the arithmetic and the logical unit. What about this control? What about this control? What about the control? Why we have a control over there? Why we have control over there? Keval? It will be set the signal bit. Okay, control the operation. Jaishankar, very good. Firstly, what you said is also correct. If I want to transfer the data from ALU to register or register to ALU, that thing don't happen without using the controller. Otherwise શું થઈ જાય, એક જ બસ હોય તમારી પાસે, ડેટા બસ અને એડ્રેસ બસ. એમાં જો સામે સામે ડેટા અથડાય તો ડેટા ના તો રીડ થાય ના તો રાઇટ થાય. So who will control the things? The control block will control the flow of sequence, that which data will go to the register, to ALU, ALU to register. Okay, I know about this. Going to the computer structure, if you want to discuss anything about the computer structure, these 4 parameters are very important. First, the instruction format, addressing modes, instruction set, and the general organization of the CPU register. That means architecture. What do you mean by the instruction format? What are the things are present in a instruction format? What are the things? What do you think? Opcode and operand. Very good, Harshit. That is what. And based on that only you can able to decide how many bit your processor is, whether it's a 32-bit, whether it's a 16-bit, you can decide on that only. What about the addressing modes? Must required, because I need to do the direct, indirect, immediate, or if I need an what do you call it, register indirect, register direct addressing modes to do some kind of operations. I must have instruction sets, arithmetic, logical instruction sets, and last, general purpose structure. I remember we have discussed the 2 things. The CPU architecture. One is a one Neumann architecture and Harvard architecture. What is the difference in von Neumann and Harvard architecture? What is the difference in the von Neumann and Harvard architecture? Yes, Harshit, Jaishankar, Keval Raj. What are the difference? In which architecture we have a same memory or a separate memory? Von Neumann or Harvard? In a von Neumann or a Harvard, we have a same memory, data memory and the program memory. Correct. Harvard have a separate? Correct. Harvard have a separate memory. So it is easy to read and write the things. If you have a same memory, it takes time because it need to go to the branching. You have to use from memory to data, data to memory, that, and then to the process. It takes time. So Harvard is a very fast processing and it can be used for a small applications. Type of architecture. This is what we had seen. We have 2 separate memory, the instruction memory and a data memory. Both are different in Harvard. So if I compare, these are the things we had compared, correct? The flexibility, speed, an example. Harvard is speedy, flexible. Who is flexible? Von Neumann is more flexible because it have one memory. So you can decide up to what you need a memory, data memory, and up to what you need in data memory or a program memory. So that is what we call flexibility. But in the Harvard we have 2 separate memory that is always be fixed. Okay, 128 kilobyte and a 128 kilobyte હોય તો સેમ જ હોય, પણ એ બે 128 ને ભેગી રાખો અને if can decide, let's suppose 64 kilobyte I need to use for program memory and બાકીની જે વધી છે એ મારે data memory સાથે use કરવી છે. So that is a more flexibility you will get in the von Neumann architecture. This is the architecture we had seen, I remember. So we have a general purpose register organization. Why we have a selection A, selection B? Total how many registers we have first of all? Total 7 registers we have. Now each registers are connected to multiplexer because I need to do this operation R2 plus R3. That means the data of R2 and R3 are added and must store the data into R1. So how things are doing over here? Can anyone say about the selection A, selection B operation and the selection D? These are the important factors. Why we have selection A, selection B? Why we have selection A, selection B? Architecture. Selection A use करे तो શું થાય? Selection B use करे તો શું થાય? Control input. What do you mean by that? Let's suppose selection A. If I need A bus as a R2 and B bus as a R3, what should be the selection A and selection B? I hope everyone knows about the multiplexer. If I need an A bus as an R2 and B bus as an R3, what should be the value in selection A and selection B? One zero and 1 1. How many bits total we required in selection A and selection B? How many total bits we require? 3 bits. Why? Because total 8 inputs, 7 inputs are there. So 2 raised to 3. So how many bits we require? 3 bits. So once you will give the selection A as a 0 1 0, R2 will be in the A bus, and selection B, if you write 0 1 1, the R3 will be in the B bus. Now, okay, once R2 is here, one R3 is here. Why I require the operations? This is a multiplexer only, ALU. What do you mean by operation? It's not an op. What actually the operation stands for there? Why the operation stands for there? Okay, sum. Or it sum. Okay, what do you mean by sum? Let's suppose here I need to do the sum. That means if I write like this, R2 minus R3, I need to do subtraction. If I write R2 multiply R3, I need to do multiplication. If I write R2 divided by R3, I need to do division. So ALU can able to do many things, arithmetic as well as logical. Let's suppose if I tell R2 and operation with R3, there is logical operations. So how the ALU decide what kind of operations you require? That means you must have some selection inputs. So this is the operation decides what kind of operation you need to do. Let's suppose if I'll put it here, the 0 0 1 0 1, it will do the addition operation. Can you tell me total how many different operations can able to performed in the ALU? Total how many? So how many operations can be performed with ALU based on this structure? What do you think? 32. How is passive? 32. Very good. Correct answer. Or 32. How is 32? 2 raised to 5, because 5 bits are there, so total operation is 2 raised to 5. That is 32. Very good. Okay, after doing the addition, I got an output. Where I have to store? In R1. So what I need to do? This output will go to the each and every register, but I don't want to write each and every register. Where I need to write? In R1 only. Who will select that R1? Selection D. This is the decoder. What I'll do? I'll write 0 0 1. So 0 0 1 means it will select only R1. It will enable R1, and this data will be written into R1. Clear this thing? The diagram clear? All of you? Just have a look for this diagram for 2 minutes, and if you have any doubt, you can write it down in the chat box. The step by step, 3 steps have been written, 4 steps. So look at the 4th step. If you have any doubt, let me know. Yes. Okay. Good. Now we'll go to this. What should be the size of control word? Can you say? The question. What should be the size of a control word? Selection A, selection B, and operation. Total, how many bits you required? 14. Okay, 5 for operations, 3 for selection A, 3 for selection B, and 3 for selection D. Total, this is what? The operations R1, R2, R3 if you need to select, and this is the operation. Transfer A, XOR, decrement, increment, are the things you already studied. Yeah? I suppose, write down this answer for this. Might be some of them already have the presentation, but those who don't have the presentation of mine can write the answer. Selection A, selection B. I need to do this operation. Before that, you just take the screenshot of this slide, and only then you can write that thing. Take a screenshot of this slide. Okay, and then try to give answer for this, all of you. Write your answer in a chat box. Jaishankar, Abhishek. Okay. Jaishankar and all. Good. So we'll put it up to here. Next time we'll discuss the next thing about the register push and pop. Okay, all of you. Fine. Start writing the enrollment numbers from sequence. enrollment number. Who is first? Once they wrote, please leave. Start writing the enrollment number. Who is the first enrollment number? Write in a sequence. Jay, Mulakis. Okay, enrollment. 001. Okay. Keep in. Don't write in between now. Who is after 22? 23, 24, 25, 26. Okay. Those who wrote, they can leave. Okay. Don't wait for this. Wait, it will write it again when it turns come back. Okay. There's no one after 41 to 46, right? Not. Okay. 56, correct, Buddha? 57. Okay. Easy. Those who wrote, they can leave.
Sir,
Yes?
will you note my attendance? Actually, I have some network issues.
Tell me.
040.
Okay.
Thank you, sir.
Hello, sir.
Yes?
Sir, I'm 17 series student.
Tell me. Write it down.
Okay, sir.
Hello, sir.
Yes?
Sir, 139. I am not able to tell.
Hello, sir.
Yes?
I'm a D2D student.
Write it down enrollment number. What is that?
Okay, I wrote in the
D2D
message.
students write the complete, write it down the complete enrollment number.
Okay.
Done. Shankar, anything else?